So hello everyone, I hope you're enjoying the event, and I know that the next thing after this is lunch, and I know it's gonna be hard to compete with that, so I will try to be on time, though I'm already like 20 minutes late. So stay with me, because honestly this talk is absolutely packed with a lot of knowledge. I think it could easily be like 3 talks or so. And the title of the presentation is Fast Nuxt.js applications with PRPL pattern. So as I was introduced, my name is Filip Rakowski. I'm a CTO and co-founder of Allokai. I'm quite sure no one here heard about Allokai, but maybe, I really hope, some of you heard about this, Vue Storefront. Anyone? Raise your hand. Not many people. We're not doing that well in the US. Okay. We rebranded, basically, from Vue Storefront to Allokai, but if you didn't know Vue Storefront, it's like, it actually not a big thing for you. Though, what we are doing in general, like if you're building any kind of e-commerce applications, especially headless ones, you probably need a storefront, you probably need like an orchestration layer, an UI library, and things like that. So basically, we deliver that. We're open source to some degree, so you can just check Allokai or Vue Storefront on GitHub, and you can learn more about us. But this is not what we'll be talking about today, though part of what we are doing at Allokai is actually strictly related to that. Because today I will talk about web performance, which is one of my absolutely favorite topics to talk. As you can guess, the second one is e-commerce. And it's a niche I've been at for the last 7 years or so. And it's amazing, really amazing that even after such a long time doing something, you're still learning a lot of stuff. And in web performance, it's basically digging into how things work. And, you know, we saw so many new APIs introduced by browsers, by frameworks, by meta frameworks since then, that allows developers to get even more control over like everything that is happening on their applications, which as a result, at least, should allow them to tweak performance a little bit better. So since single page applications became a thing, like around 2016, 17, it was like probably the biggest rise of that concept. We've seen the introductions of APIs like resource hints, not allowed to prefetch, preload, or even pre-render the whole pages. Absolutely a game changer in terms of like controlling what has to be downloaded first, and also prefetching some stuff. How many of you are using this API? A lot of you is using this API without knowing this, and you will learn about that. How many of you is using Nuxt? You just don't like raising your hands. I don't believe that. Okay. Also, another thing, ability to decide the fetch priority of images and videos. This is quite a cool stuff. Another thing, and this is my absolute favorite, SEO-friendly native image lazy loading without any third-party scripts. Like, a lot has happened since that time. Also, not to mention the framework concept of server components. That is a super hot topic in the Vue.js community and in the React community. And, you know, people in the React ecosystem, they're still trying to understand like the core concept and mental model of those server components. The people in the Vue space, well, they are happy they have Nuxt. But I remember when I was stepping into this world of web performance, and it all felt so complicated, it all felt extremely hard. And I learned only like many years later, actually, that the whole web performance optimization, like everything that we're doing there, it really boils down to like a very simple pattern. One simple pattern that persisted throughout years since 2015 or so, just like all these classic design patterns. So literally every time you encounter someone, if you do this on your own, optimizing a web application, they are utilizing this single pattern, either consciously or subconsciously very often. And that's the essence of what I want to share with you during this talk, this particular pattern. And just a quick disclaimer, by web performance, I mean loading performance, since this is what we are all struggling with, and there is a lot of data to back it up. I won't cover some niche areas of performance like optimization of a memory of a CPU or like a 3D rendering, this sort of things. Even though they're interesting and fascinating topics, I absolutely have no idea about anything related to that. In today's presentation, I want to share with you those rules of this, ultimate performance pattern that, well, is being implemented by Nuxt pretty effectively, that we will learn very soon. But also what tools Nuxt is giving us to actually not ruin what they're giving out of the box. And almost everything that you will learn today is transferable. So you can use it with Nuxt 2, with Nuxt 3, with Nuxt 4, that is upcoming. You can use it with React, you can use it with Quick, you can use it with Astro, because The same pattern is being used by all the frameworks out there, and actually I will dig into that a little bit during today's talk. Because again, tools, they're changing very often. Yeah, we need to learn tools. We need to learn tools to build something, but patterns, they persist. And if you know patterns, every new tool that you will learn, you will quickly be able to adapt to this mental model. So it is a very good investment of everyone's time to actually learn those patterns, because it is also shortening the time of learning the tools. And the general problem that I always have with remembering the acronyms of any kind of patterns is that I remember them wrong. And it's often causes very weird situations. But luckily, this particular one is very simple, and you don't even need to remember the letters, or you don't really need to make any kind of like a weird association in your head. You only need to remember the color. And I hope, you know, this color will actually be what it is on those screens. The color is purple, and the 4 letters behind purple pattern stand for the 4 rules you need to follow to keep your application fast. How many of you, I know that you're very hesitant to raise hands, but like try it once at least, please. How many of you ever heard about purple pattern before? Come on. 2 people. I will be waiting for 2 people. Okay, this is actually great news because I have a great audience, because I have absolutely no idea what I'm talking about, so I can tell you about anything. And I will still be considered a subject matter expert, which is great. So we have 4 simple rules that fuel the whole web performance industry. And let's learn about them and understand them. So the first P. The first P stands for pushing critical resources to the initial route. What are critical resources? Well, these are simply the resources that are quite essential, or just essential, to render the view in front of the eyes of the user. So anything else, like off-screen components, maybe some interactivity, that is being fueled, things below the fold. This is not a critical resource. A critical resource is a thing that is absolutely essential to render the initial view in front of the eyes of the user. And the goal of this step is to deliver this as soon as possible to the end user, because usually before that happens, they absolutely see nothing. So it can be like an index HTML file, for example. Once those resources are available, we use them to render the view in the browser. And this mostly means that those critical resources are being handled by the browser before anything else. So if there are any other tasks that the browser could handle, like it's being postponed, the first, it is focusing on rendering the view. And even though this is not a part of the official PRPL pattern, I think in the context of single-page applications, it is worth adding to this part that we don't only need to render this, but also to make it interactive as soon as possible, because there's nothing more frustrating than just clicking on something that just doesn't work. And it turns out to be a huge problem with hydration. I'm quite sure you encounter this. So this is a pretty common issue in the single-page application. So we're also adding interactivity into this part. And once this initial route is already rendered, we should make sure that we also download the remaining non-critical resources. So when user scrolls below the fold or clicks on like something that triggers a modal window or something that has to be interactive, it is appearing immediately. It is responding immediately without any delay. And the purple pattern in general focuses on optimizing this initial load. Like that's the whole point of this. No other resources get loaded. No other code is executed before the initial route has loaded and rendered completely and is interactive. And we can achieve this by code splitting our application to smaller performance chunks. Code splitting, as the name suggests, is like splitting the whole code of your application into like smaller bundles and loading them when there is the right time to load them, not earlier. So congrats, really. You just learned the universal pattern used in any kind of loading performance optimization. And everything you learn from now will be basically a technique that is applying this, or how someone is using that, for example, Nuxt. But yet it is essential to know this because, well, we know patterns, now let's learn how to use them. But in general, like, please remember those 4 words, because every time you encounter any kind of like a web performance problem, it's most likely there's some issue with one of those rules. Like most likely some of them are just broken. So let's learn what techniques are already used behind the scenes by Nuxt to automatically, implement this pattern. And what tools we actually have available in our application, like from the Nuxt core, to not ruin what Nuxt is giving out of the box. And the truth is, Nuxt is doing a lot out of the box. It's extremely efficient, and you don't need to follow many additional rules to ensure that your application loads efficiently. So let's start with the first one. First of all, Nuxt really automatically identifies which JavaScript resources are critical and uses preload resource hint that we talked about a moment ago to make sure that they're downloaded before any other asset. So if you will then look into the network tab, you will indeed see that these two scripts, they were downloaded right after the initial HTML was parsed and discovered those dependencies. So the first stage is kind of checked. Critical resources are being pushed to the browser by Nuxt automatically. How about rendering the initial route? Well, the great thing about Nuxt is that it is already rendering everything on the server. So technically, we don't need any JavaScript to run on the client side to render the initial view. Once the HTML arrives to the browser, together with the CSS, which is render blocking, which means that until the CSS is parsed, we won't be rendering any HTML. It also can be very often a bottleneck. Like if you have a huge external CSS file to actually delay rendering, it's rarely a bottleneck. Like in applications that are using Tailwind, it is very often a bottleneck in applications that are not using Tailwind. So once it arrives to the browser, the user immediately sees the view. And honestly, in single-page applications, it is extremely hard to make this part right if you're not having SSR rendering. Because then you're basically downloading a blank HTML file, the whole JavaScript code has to run, then it's painting the view. It is taking often like 10-15 seconds on mobile devices. It's a nightmare. So SSR is definitely something that is helping tremendously with achieving great performance, great perceived performance as well. Last but definitely not least, Nuxt automatically code splits our code and each route of the application as well as corresponding components and composables. So the way this framework takes a little bit of work out of our hands by just taking some common parts that are usually becoming a bottlenecks and making sure that they are handled properly. And I think, honestly, like this is something that all the frameworks should be doing these days. Like they should take as much work out of our hands, as much optimizations and like low-level things, so they can just focus on shipping stuff. So Nuxt is doing a great job in here. It is automatically splitting the routes. It is automatically adding composables and components associated with those routes into proper bundles. So with this approach, we can be more or less sure that the critical resources that we've been talking about at the first stage, they're bundled together with the initial route. And there's one more step that is not covered by Nuxt out of the box, but can easily be added with a single Nuxt module, which is lazy loading, which is pre-caching the remaining routes. So there is a vue.js Nuxt plugin, which is kind of like a spiritual successor of Nuxt PWA module. I looked it up actually today. The last release of the Nuxt PWA module is 2021, while this one is actually actively maintained. So I'm highly recommending to use this. And it does a lot of things, really. Like if you go to the landing page, there's like 15 or 16 bullet points. But the one that is interesting to us is pre-caching all JavaScript assets that we're generating during the build time. What is pre-caching? Well, when the browser is in the idle mode, so when it finished rendering the critical path and when everything is done, then silently in the background it's also downloading all the other assets that were generated during build time. So the next time we go, for example, to the next route and we need some specific bundle, it is already there in the memory. So it is making our application more efficient by making sure that whenever a user is requesting another route, they don't need to wait to download this. It's already there. And these resources, they're called app shell. And now on the next visit, also your application will be served from cache, which is quite cool. It is also allowing to offline browsing. But with SSR, it is even more powerful because this app shell, for example, the index.html file, well, it basically has the whole page. So to summarize, how Nuxt is implementing the purple pattern out of the box. First of all, it is preloading the critical resources. We already saw that. Secondly, it is rendering the initial route on the server side, which is great to have this route rendered as soon as possible. The third thing is it is automatically splitting the code of the routes, of composables, of components. This is super cool, really. And with vue.js module, we can actually push that further and also cache the static resources. So they're not only available later, but also on the repeated visits, they're loaded basically from cache. Okay, so a fair question to ask here is, okay, Nuxt is pretty well optimized out of the box, how we cannot ruin this. What steps we can take to actually keep this software being well optimized? Well, I will start with two things, really like two key things that could go wrong. The first thing is, and the first issue that you can encounter is growing HTML file. So this initial HTML file that is coming from the server, it can grow to the point where it's so big that it is taking a few seconds to download this. And in this situation, the users is just staring from the blank screen. And the attention span of people in general is like around a few seconds. After 1 second, there's been studies on that. After 1 second, someone is doing a mental context switch. So probably they're going to browse another tab, taking their phone off or anything else. So this is how we can lose customers. So it's extremely important to have this HTML file as small as possible. But sometimes it can grow significantly. Why? Like why we're running into this problem? How this could happen? Well, Nuxt is quite smart and it doesn't fetch the same data twice. So when we fetch some data on the server side, it is actually including this data into the HTML. At the very bottom of the page, you can actually find it and it looks more or less like this. And then when it is being transferred to the front end, it's not fetching it again. It's actually picking up from this object to fuel the single page application. And well, if you have a lot of data in there, if you're doing a lot of overfetching, if you're, for example, having a product listing page with 200 products and each of these products has, I don't know, 100 properties, this file is going to be huge. This is why it's absolutely essential to ensure that only critical data is transferred to the client side and there's absolutely no overfetching. A good example is, so I mentioned this product page. Like we're displaying just product types. We can display 20 of them, 200 of them. Each of the products could have like 100 properties. In reality, we only need 3. We need product price, product name, and the thumbnail. Everything else can be stripped. So here, you have an example of what you can do about that. If you're using REST APIs, because in GraphQL it's quite trivial to get exactly the data that you need. If you're using REST APIs, you can use API routes or server routes in Nuxt to act as a middleware between your front-end application and the API and just strip this data. Just deliver only the data that the front-end needs and nothing else. This way you will keep your HTML file lightweight. Another way of reducing the data payload of the initial HTML file is just not fetching some data on the server side. The reality is not all the data has to be served from the server side. I will tell more. Some of the data should never be served from the server side. If you're using a CDN, if you're caching things, you shouldn't cache personalized data. Because if you do this, then something that is personalized for one user will be delivered for the CDN to the other user. And you will have Mike, and Mike will see a web page that is saying, hello, Jasmine, which is definitely not a good user experience. So you can use fetch flag server false to actually fetch some content only on the client side and ensure that it is not being cached, but also not being included into this HTML file. Okay, based on my experience, the size of this initial HTML file is rarely a real bottleneck. And if it is a bottleneck, then it's exactly that case. We're overfetching data. Now let's get to the biggest troublemaker, which is JavaScript. And this is something, whoa, that could grow very significantly. And why is such a problem? Well, when you have a lot of JavaScript, what happens is that, yes, the user sees this initial page, like everything is rendered, but when they want to make some kind of an interaction, they're clicking on something, like nothing happens. Why nothing happens? Because the browser is single-threaded, and it is usually occupied parsing a huge JavaScript file. And until that happens, they cannot accept any interaction from the user. It is being actually queued, and it is waiting until this huge JavaScript file is being parsed. So what we should do is we should ensure that this initial JavaScript, this critical JavaScript file, is so small that it's being parsed almost instantly. And when the user clicks on something, they are seeing the response immediately. And I'm sure you encounter this. I'm sure you encounter this a lot of times when you're visiting a website. It's very often happening on the mobile phone. You're immediately clicking on something, and then nothing happens. I know the answer, but raise your hand if you encounter this. Oh, yes. Good, good. So it is quite common. And this is exactly because single-page applications ship a lot of JavaScript. And it is a super common problem. And frankly, this is a design flaw of single-page application per se. Like, we're only fixing it right now after realizing the mistakes that we have done as an industry. And this is why you should really take care of that. It won't happen automatically. Yeah, so we have to make sure that those interactions, they are happening without delays. For that, we really need to split our JavaScript code into two groups. The code that needs to run as soon as possible, that is ideally only the framework, maybe with some additional libraries like Vue Router and things like that. Maybe some critical tracking scripts, maybe the code for the initial route. That's it. And then code that can be loaded later and is needed only as a response to users' interaction. The reality is 90% of the code that is not your library is like that. And again, the former, it is already taken care of by the snippet that we've discussed some time ago. It's a great starting point, but it's super easy to ruin it. So how not to ruin it? Well, let's first understand how we are actually introducing JavaScript to our application. We can simplify this to two key elements, components and plugins. And keep in mind also that modules, they can also inject plugins. It is still components and plugins, but if you really want to know, like if the module that you're installing won't accidentally add you like 200 kilobytes of JavaScript, and if it is open source, it is just worth going to GitHub, looking at the source, looking for add plugin statement, and then clicking on the path and seeing if it is actually not including some huge library. I know this is super nerdy, but actually it's quite good to do this. So, coming back to our bundle contributions. When it comes to components, they can be rendered in three ways. It can be rendered as server-only components. So, Nuxt has an experimental feature called server components, which is an absolute breakthrough for web performance. And they're quite easy to understand. In short, Nuxt server components render only once on the server, so the HTML is rendered. And then when it arrives to the client side, to the browser, it is not downloading JavaScript associated with that. Like the component is done. It is rendered, it is never interactive, it's just purely static HTML. And in Nuxt, server components are also called islands. And it is kind of like an opposite approach than in Astro. In Astro, you have interactivity islands. In Nuxt, you have non-interactivity islands. And my recommendation would be to think server components first as a good default. So think about every component as a component that is the server first and non-interactive. And even though Nuxt is not enforcing it on us, we can enforce it on ourselves. And this way you introduce new code to your bundle consciously and only when it is really needed. And using component islands, or how I prefer to call them server components, and let's call them server components, in Nuxt is that simple. So first you need to enable this in the config because it is still like an experimental feature. And once the server components are enabled, you can specify which components in your component tree are server by just adding a server prefix to the name. That's it. Like, that's the only thing that you need to know. And I think this is a great approach because the reality is we don't do this selectively. Like if a component is a server one, it is server one in all the possible occurrences. And we can very easily refactor some components to be server first, just change the name. And in all of our application, it is just much more lightweight. And a great thing is that since Nuxt 3.11 actually, since Nuxt 3.11, this is also available for pages. So you can have a full page that is server only. And you should definitely use it for pages like blocks. And even if this block has some interactive elements, you can also go to the Nuxt release notes of 3.11, and you can also selectively, within server-side rendered pages, server-only pages, mark some components as interactive, which is quite cool. So it's kind of like the opposite of the server components. And when you look at the code, at the template code, the server components, they're indistinguishable from the template. You just use them as a regular components. That's why refactoring is actually quite easy and quite cool. Okay, what if we nicked in the interactivity? Like single page applications, they are called applications for a reason, right? Even though the most of them, I think, should be just static websites. And like the reality, like most of the single page applications that we build nowadays could just be a simple multi-page applications. Some of them need interactivity, and server components won't be sufficient. So what to do then? Well, even if a component needs some kind of interactivity, there are clever ways of adding it. And another thing is that we almost never need interactivity up front. And I want you to think about this for a short moment. Like we almost always need interactivity as a result of some kind of interaction. This interaction could be a click. This interaction could be a hover, or when the below default element actually apports to the viewport. Like there are really few elements that need this interactivity up front. This is why I said before that 90% of the code you can lazy load. And we can always delay the JavaScript code execution until this moment happens. And the concept is generally called lazy loading. Like this is what we're doing when we want to delay execution of some JavaScript code. And in the context of components, we called it lazy hydration. I won't be getting deep into that topic because Alex Lichter has a whole talk about this tomorrow. For now, I think about this as lazy loading, but for components, and that's a perfectly good mental model. So there's a great library made by Jacob Andrzejewski, who works at Allokai actually, which is inspired by another library from Markus Oberlechner, and that brings a lazy hydrate component to Nuxt that allows you to do exactly this. And it gives you a single component that makes all kind of like a conditional lazy hydration possible. It's also worth noting that something like this, it will inevitably come to the Nuxt core. So right now we need a third party, but I'm quite sure that we'll have this in the Nuxt core very soon. I know that Daniel is constantly adding features around that. Actually, it's also Julian working on this. Anyway, how to use it? Well, it's that simple. Just wrap any component into this lazy hydrate component and specify the conditions when it should be hydrated. And that's basically it. Then the chunk of JavaScript associated with this component, it will be code split, and it will be downloaded only when this condition is met. And now it's the secret sauce. Now it's the best moment of the presentation. Now is the time to take screenshots, because I will reveal my secret formula for the fast components that if you follow, I guarantee, or money back, that your components and that your JavaScript will be loaded as efficiently as possible. So are you ready? Woo! Yeah, come on, like you can have more energy. I know that there's lunch out there, but yes, are you ready? Good. Okay, so there is a decision tree. Oh yeah, it's there. There is a decision tree that we personally advise our customers to follow at the Allokai, and this is something that I'm personally using. And what it says is that basically we treat all the components as server ones. That's the default. And think twice if they even need interactivity. And in most of the cases, they just don't. As a side note, if the interactivity is needed, I really encourage you to sometimes think if actually need the whole instance of a component just to open a modal. Maybe a CSS would do this. A CSS, it's not the dead language. You can still use it in single-page applications. And I highly encourage you to actually do this. Okay, but there are some things that cannot be done with CSS, right? So if this is, for example, a data interactivity, we need to think if the elements needs to be interactive immediately or as a result of some interaction. And then, like, if it is a result of some interaction, there's almost always a result of some interaction, we can use lazy hydration. Now, even if an element needs to really be interactive immediately, so this is like this rare, like a small subset of all of this, we can still use rule when visible from the lazy hydration component, which means that if this is below default or if someone has a small screen, it will become interactive only when it appears to the viewport. So really the only case when you'd like to download the JavaScript chunk eagerly and put it maybe even as part of your critical resource and execute it is, well, maybe 1% of all of the components. And if you ever wondered, for example, why Astro is so fast, this is why. They also use server components by default, and you opt in for interactivity. This way, Astro applications are generally much faster. They have much smaller JavaScript footprints, though it's worth noting that they're also usually much less complex than Nuxt applications. So it's not comparing apples to apples. Like in Astro, you usually mostly have blocks. But the concept that I just told you, it is being heavily utilized in Astro. And in Quick, like, have you heard about Quick? A new framework. Also, Angular right now, it is utilizing exactly the same approach, which is called resumability. It's even simpler because the framework does all of that automatically for us. So this whole decision tree, it is being handled by framework. In Quick, it's even better because it is also more granular. Like every interaction is a separate chunk, but like that's the point. Like this whole formula in Nuxt, well, you need to do this manually, but nothing is stopping you from doing that. Nothing is stopping you from having a great performance in Nuxt.js just by thinking server first. Just by thinking, okay, like if it has to be interactive, let's delay this. If I cannot delay this, maybe it is actually below default and I can actually delay this. And if I cannot that, maybe I can load this only when the browser is idle. Like always think how you can delay the execution of any JavaScript chunk because in 99% of cases, like you can do this. Going back to the main topic. We inject a lot of third-party codes also with components, but sometimes we also do this through plugins when we need something to be globally available. And the funny thing is, for plugins, you have exactly the same concept. So there could be a server plugins and a client plugins. It's that simple. And if you have like components, for example, server components that are using some data from plugins, it is worth marking those plugins as server only. It is worth noting that if for some reason you will specify the island property in the plugin as false, then it just won't work. So we have exactly the same decision tree for plugins. If we are having a library that is basically used only once, for example, to render Markdown or things like that, then it is just worth using it as server-only plugin. Okay, we talked about data already, but there is also a JavaScript component into the data. So let's get back to this topic just for a short moment. So there are generally two things that we do with data all the time that could impact our bundle size negatively. And the truth is, frontend shouldn't take care of those things at all. So those two things is we could fetch the data with a vendor SDK. And very often when you're using some third-party service, they're telling you that, okay, like you need to install this SDK. This SDK sometimes weighs 10 kilobytes, sometimes it weighs 100 kilobytes. Imagine you're using 7 APIs, you're installing 7 things like that. You have 700 kilobytes of the application just to fetch the data. Another one is transforming with JavaScript libraries. And there's a famous example of Lodash. Lodash is quite heavy library when you're using a lot of its utilities. And these things, they really shouldn't be handled from the front end. And I think this is kind of like a pathology that modern front ends, they are so heavy with the business logic. They should really just get the data and display it. Like everything else should happen in the middle layer. And we have API routes for that. So again, we will use those server routes to keep the third-party libraries on the server side. And here's an example of how something like this can be done. You can do this for each API call that requires you to use a heavy SDK. Keep in mind that some SDKs also have a front-end functionality like Storyblock, but in general, they are purely wrappers around the API, and for some reason, they are extremely heavy. So use this for every time you need to add an expensive SDK. Do this on the server side. Use it every time you need to transform the data with some heavy data transformation library. Then your frontend will be super lightweight, and I think that's really what matters. So let's summarize what we learned in this part and how not to ruin Nuxt speed while adding new features. We already know that Nuxt is extremely optimized out of the box, and we also know that we can ruin it basically two ways. One way is making this initial HTML huge, and this is quite easy to optimize. Just don't do overfetching, don't include too much data in this HTML. And the second one is that we can do this by, well, basically including too much JavaScript that is blocking the interactivity of the application. And for that, there are different ways of handling that, but generally we should think server first. We should use lazy hydration. We should think about server-side plugins. We can even think about server-side pages. And also when you're dealing with the data, please do the transformations, patch it on the middle layer, so you're not adding additional JavaScript to the front-end side. And that's it. Thank you so much for being with me, especially that there is a lunch happening there. I'm really flattered that you decided to stay here. So thank you. If you would like to, say hi to me, ask some questions, or maybe just learn about some JavaScript tips. I'm posting them from time to time when I have a motivation. I don't have it for the last month, but who knows, maybe it will happen next month. You can also follow me on Twitter, which is called X right now, but it's still Twitter. Thank you so much. Have fun and enjoy the event. Bye.